Gatekeeper amps.
Does this ring a bell for anybody? Maybe bring back some old memories. The old golden eagles. This was sent to me down by my buddy the Lunchbox. He's been waiting a while for me to get started on this, poor fellow. Here's this little box I texted you about. I've only tested that one time. Just staying keyed up after unkey. I'd like to get it all in working order. Refresh. That's a big statement there. I'll be keying up with the Magnum S3 dual final radio. Whew. I might have to add some attenuation this thing. I don't know. By my buddy, Lunchbox. Let me see what the back says. Okay. Yes, it's personal information. This is what we're looking at here. This is one of them older boxes that do something that I don't agree with, which is bringing in the power wire to the front switch right here. And they're letting the DC flow through the front switch. Of course, I ain't saying that it won't work. But I mean, look, we're bringing this thick wire in, soldering it to the lead of the diode. Does that remind you of any other amps out there, y'all? There's our and then we're allowing that to go to that. And then it's leaving there and powering the transformer. Obviously through a trace. Well, yeah, through a trace. This trace right here. What we're probably going to do is we're going to take the power wires completely out. We're going to bring the power wire in this direction. Make a bus somewhere over here, or take it, or we may change this whole output transformer. We'll see. I need to look at everything, and we'll bring the ground in this direction, put it straight basically where it's at right there, but just bring it in the other direction. Because if you notice, you got a clean spot for it to come in this direction. And we definitely will be removing this, micing this in. Yeah, definitely will be replacing that. That cap's gone, man. With how old this box is, there's no way any electrolytics in this thing's still working hardly, you wouldn't think. I've seen right here on the lid, possibly the last time this was worked on in 1984 by Mr. Mike Madden. The RX relay, the power LED, the TX relay cover. So this TX relay cover was changed, or somebody's done hit it with a soldering iron. Rework the TX section. So they replaced this whole RX relay there. Well, they did a good job on the transmit section. You can tell they had to remove that board to do all that, looking that good. Alright, man, we'll do our thing, do a refresh. Let's just show you what it's doing right now. That's just going through it. Yeah, I still got the leads hooked up. I hooked it up the other day. Just taking a gander at it. Sorry, I dropped my phone. It is, I sliced my finger open with some scissors. Can you believe that? Some scissors. All the sharp things I work with around here. I'm going to slice my dang finger open with some scissors. Trying to open a box with some scissors while I was holding my food in with my other hand. I couldn't wait till after I ate to see what goodies I had that came in the box. Tell you what, man, being 41 years old, still can't wait. Still like a kid when it comes to getting in new prizes and stuff in the mail. Alright, so like I said, this is going to, it's sticking. I watched a very cool video on LEDs today, and how it took so long for them to learn and figure out how to make an LED for a blue LED, how to make a blue LED. So the red came first, the green came second. And if they could figure out how to make a blue one, then they could make a white one and yellow one and other colors. But they had to figure out how to make that blue one first. And it was a Japanese or Chinese, I think a Chinese gentleman went against the grain and figured it out with a unique reactor, because they actually grow their crystals with a reactor to make LEDs. I used to think they went out and mined them. I ain't kidding you. That's what I had heard. It comes from a crystal, a rock, or whatever, you know. That's what I had heard, which that may be true in the beginning, but they learned how to grow the crystals that they need. And the actual emitting part of the LED is very tiny in between the two leads down in there. Using doping techniques, stuff like that, man. The P-type, M-type, P-type and M-type sandwiched just together, the perfect sequence apart to create an emitting light. It's so cool, man. Something so small we use. So I guess that's so when you're using a blue LED, that was the last LED to be made that went ahead and made basically the ability to have this. Without that blue LED, we would not have had this. It's really cool stuff, man. Really cool stuff. But anyway, let's see what this thing's doing. Oh, by the way, really cool, this meter works. Oh, that is so cool. All right. Oh, we got a lot of input reflect right there. I thought it was working. I could have swore it was working. Make sure my coax is on good. Oh, well, I got the input reflect fixed. Oh, this ain't making no power. Let me put it on high. Oh, yeah. Yeah, something's up. Give me 1 second. I thought this box was working at least. Alright, it wasn't the amp, it's my dang peak kit and that bird meter. I don't know what's going on with it. Like, it'll work and I'll come back and it's not working. I'll go remove the batteries and put them back in, it starts working. I don't know what the heck's going on with that meter. It's starting to get on my nerves. I got another meter that's got a peak kit in it I can start using for a backup if I have to, but that is getting on my nerves. And there's something unique about this relay. Let me listen here. Alright, we heard the relay key. Alright, the relay has not unkeyed. Alright, here's our output. So we're getting about 95 watts, and we got a good bit of input reflect. About a half a watt. 5 watt scale. Now, about 95 watts. Now the issue we're having here doesn't appear to be a sticking or oscillation issue, because I've already checked it out and it's not getting hot. There's no oscillate. It's not sticking or oscillating. It appears to be a actual key-in circuit issue or something weird like that. But if you'll notice, there is no electrolytic on here, because this is probably using a PNP. So since it's a PNP, you get lucky and don't need an electrolytic. You ever notice how Texas Stars don't have electrolytics on their key-in circuits? One of these days I'll explain why. Alright, so these transistors are not getting hot right now. They're not oscillating. So that's a mechanical issue with the parts. And what's so weird, I'm going to turn the power off, okay? The power's off. The LED is off. There's no more power left in this amp. But you will sit here for a minute. Take a good minute and you will hear that relay disengage. It's still engaged right now. Let's just chill here for a second. It may be a relay issue, I don't know. The relay may be just keep getting stuck in this position for some reason. There it is. It looks like that's what's going on. If you see how I just tapped it, it went back. Let's try it again. Unkey. Looks like it about went back. Yeah, we're gonna need a new relay. Key. Yeah, I might have to remove this whole board. Key. Unkey. So it is a flat out mechanical issue. At least I know now. At least I know. Now this thing utilizes some neat circuits for the RF light here. You actually got you an RF light that gets brighter and dimmer as you talk. And it's doing it. It ain't even using a diode to do it like you'll see some. It's just grabbing a little bit of the RF straight from the RF output line and going up here. I may draw some schematics of this. There's probably a schematic for this amp on CB Tricks. I'll have to see and look. Look and see, I meant. But I want to see exactly what they're doing with this high-low switch, because there's a lot of resistors going on here just for this. And if you'll look, the way they're getting their RF for this metering circuit over here, it goes through that 220 ohm resistor. You know, this ain't, you can see this ain't Teflon wire. You can see it's choked 8 up. But it comes up here to the RF LED, okay, and then it carries on through this resistor right here. Alright, and then you got some glue and stuff. I'm going to remove all that. There ain't no need for all that. It carries on with that through this big gunk of wires here. So I'm gonna clean all this up. I don't like that at all whatsoever. I really don't. If I had more of my plugs I like to use, I would use that for all of these and do a whole cleanup job. I mean, you can always go further than you really want to go with these amps. He didn't tell me to work my magic or, you know, certain terms like that. He wants a refresh. So I'm not going to go nuts with this thing and just turn this thing into a Cadillac or something. You know, like, the reason why I do my LEDs the way I do, using 3mm LEDs and everything, it keeps me from having to go with a ground wire down, ground wire down, ground wire down, ground wire down the board. It keeps things so neat, because the ground wire, the ground of the LED can ground to the actual case that is being mounted to the mounting, what's the word I'm trying to think of, the mounting, the mounting thing, man. You know that goddamn thing, man. You put the dang LED, you stick it in the hole there, and put one of them damn little nuts there, and you screw the nut on. One of them things, you know what I mean? That's how us Georgia boys explain the mechanical stuff of things. The LED holder. I mean, that's just the best way to say it. My little LED holders I use. I've yet to see another person do it the way I do it. It's just something super simple. That's all it is. No bragging or nothing. It's just something I found a way, because I hated the way it looked when you had ground wires connected into the LED grounds going down the board. I just hated that. And so putting them LED holders with a little lug on there, and then bolting it down with a different type of nut that actually comes with them, so that you can really get it tight. Because the nut that comes with them things they don't have enough teeth on them. So I use nuts from other things and get that thing real good and tight, and then you can just bend it up there and you don't have to worry about the extra wire. Enough of that. All right, so I'm gonna dig into this and we'll be back. Definitely going to be removing the power wires first and all this and that. We're going to remove the board. We're going to have to replace the relay. That relay is ready to go. It's ready to be took out and sent to the relay graveyard. So we'll buy a plot for it and get a tombstone. Taking up donations for it. All right, we'll see you. All right, we're digging into this the old Nickel 150, and I ain't gonna lie, it's a mess. I mean, just look at this. It is a mess. I'll be honest with you, Lunchbox. I probably should have just said, hey, man, let me send this bad boy back to you. Wow. Now I see why it had some relay work done on it. When they replaced the relay, they damaged the trace right here, and they basically took a piece of wire and wrapped it around to connect that side of the coil to it. And I mean, I got my little circuit board holder right there. There is another trace that came loose, you see right here, and you see it came with it. And I sucked all the solder out of that thing, man. I mean, I sat there and worked with it for 20-30 minutes, putting flux on it, a little bit of solder, sucking all the solder out, and I got every bit of the solder out but that one pin. And it looks like there's a little bit of solder up on this side, but you can't get to. You just flat out can't get to. So I'm going to fix this. This is the output. I'm going to fix this on the back of the board. But before I do that, I'm going to go ahead and clean all this up and get it all cleaned up, looking good. So you can see we're down to bare board now, man. I mean, we're pretty much down to bare board. Ooh-wee. I drew a schematic here just to help me out, so I'll remember where everything goes for the high-low switch and for the meter circuit. I'm gonna get you a little lamp, but I'm gonna be honest, man. I hope this thing's got sentimental value to you, brother, because this is more work than most people would do to a small amp like this. But we're gonna get it refreshed for you. We'll get it done for you, buddy. And I'm gonna replace probably all of these resistors, redo the wiring, the whole nine, man. So we'll get it done for you. It definitely will look better than this. I'm gonna try not to go too crazy with it. Try to keep the cost of the repair down for you. So we'll be back. All right, we are now done. And wow, this little booger right here turned into a no other than what you can call a full rebuild, or as he put in his note, a full refresh. So yes, I had to remove this whole board, and to keep myself straight, we had to jot down some notes here. just to keep my my mind straight there, because everything was such a mess. When I removed everything, there'd be no way I could remember where everything went to. So I went ahead and drew down how the high-low switch was. I deleted this 10 ohm resistor. There's no reason to have that in there. I think they were just using that as a carry-on. So instead, you see, we're just doing that way. And another one was the actual RF circuit for the little meter. I had to draw that out. And then one of the biggest things is to keep myself straight is how all this is wired up. The receive LED ended up being blown, so I had to replace that. And that just gives, you know, little sentences on how the high-low switch works. Now, why did I have to go ahead and replace the transformers? Look how tiny the brass is, these holes are in these transformers. I mean, that limits you, because you need a 4 and 4 on these wraps, and that limits you with some tiny wire. So that's why I went ahead and just replaced the transformers. And see, this ain't even Teflon wire either. So I replaced the transformers with 2 of them that I made here in-house. And here's all the parts that came out. All the non-Teflon wire. Here's the old relay that was sticking. So put you a brand spanking new relay, and these are the same relays that Texas Stars use. This bulb was out. We went ahead and replaced that. Looks great. I do? Is it yellow? Yeah. That's my transistors. Good deal. Been waiting on them. Just had a brick of 120 standards come in from China. So this is what was on the output transformer. Got that off. Got that mic'd in. This thing did not have feedback circuits in it at all, so I went ahead and installed feedbacks. I went ahead and tuned the whole amplifier out using trimmers. Got that fine tuned. As you can see, I laid a bus right here. You remember the way it was before, it went all the way to the switch up here up front, and then went on that way, and the DC flowed through this circuit right here, this trace, excuse me. So instead of doing all that, we got some thick 8 gauge coming in. Then we got 16 gauge wrapped around 43B, goes directly to the back of the transformer. Now we got this wire that comes over and feeds the power switch. Powers that on and off. RF lamp works. Got it. Meter works. Got it. Got the SSB tuned in. This was the old SSB capacitor right here, which was dried out completely. I had to try 3 different values till I got the perfect value right here, because this doesn't do it the way all of us are used to going to the coil. This actually goes to the base of the transistor, and so it's way more effective. It really is. It's way more effective. So I had the first one I had on there, kept the relay keyed for 10-15 seconds, kept the relay engaged. So another thing we went ahead and did is we got a bus right here for the output. This is where it comes from. Both of these right here connects to the output going to the relay. The way it was this the winding connected right here, and then they had the output tuning cap right here to ground. So to keep all this, since we had this right here, to keep all this straight, ran me a wire from here onto the bus. There you go. Now another thing, man, I mean, this was some work. This was some work. When I removed this board, I should have recorded some video, but I was so into it. When we finally did get this relay removed, it tore up 1, 2, 3, 4 traces. You see, there's the trace right there still connected. Oh, I mean, I worked with it, put flux on it, did everything I could. It's just the problem was when this relay right here was installed, it was jammed in, meaning the holes on the board was a little bit smaller than the leads right here. So when they put it in, they jammed it hard in there. It didn't just sit in like it's really supposed to. It was jammed. So even when it's hard to get solder completely up in between them, to where the only thing I could do at that point was start prying this out while soldering. I mean, I had no other choices. So this relay was replaced. You can see right here. Tex relay. It says cover, but RX relay. I think what they actually mean was this relay was replaced, because this was completely still factory. I think they wrote RX relay, but what they meant was this relay, because I could tell this is all still factory. You can see up under the board and tell that. So what did that cause me have to do? Up under this board, I've got 3 different spots where I had to fix the traces with wire, and there's one spot where I had to drill through the actual board. Let me show you. Let me find it. It's this one right here, the output trace. This output trace, what did happen is it went down and it fed over to the board this direction. Okay, that was this right here, this, I believe. I remember right, it's this one, the one above that. So when that happened, that trace was completely came up with this. There's actually more that was on it that fell off. So the way I fixed that was I just went ahead and drilled a hole through the board, and instead of it going this direction and here, it just goes directly to the relay up on. All this is up under the board. That's the only place you can see it. The hole that was drilled is actually under this relay, so you can't see it. You'd have to have the board took out from this angle to see it. So that was a lot of work, man. I replaced every bit of wire in here with Teflon wires. You can see all the switches have been rewired. This circuit right here has been rewired, and it's just way cleaner. It's just a lot cleaner than it was. Like I said, I added the white LED. Like I said, we brought the ground the power this way, the ground over this way. Got a choke right there. Like I said, I made both of these transformers in house. I'm starting to make my own transformers now, finally. We replaced these right here with 5 watts. Because if you noticed, these right here were quite charred. Now, the only reason I didn't change that, I kept that a 2 watt, because this right here is carrying the RF over for the circuit. That don't have nothing to do with, I mean, that doesn't even need to be a 2 watt. I just left it a 2 watt like that. So another thing I had to do, since I had to, I mean, I didn't have a lot of room to put bigger power wire in here. To be able to fit these strain reliefs, it gave me a new problem that I had to figure out, a new issue, because these are the smallest strain reliefs in this size that you can get. It posed a new issue with the actual nut right here not getting too close to the board. So what I had to do is I had to actually extend the board out. If you look down here and look, I had to extend it out. Now, one positive thing about here is it's going to allow the inside, the components is going to give a breathing port for the heat of the components to go out that direction. And if somebody ever did want to cut a hole through this and add a fan to it, you'd have a port for all the excess air to go out if they ever wanted to do that. But that was the only way to get this back on here with upgrading the wires. And honestly, the way it was before was there was no grommets whatsoever. There was no grommets. The wire was just going through, and I don't do things like that. I had to put some grommets on this thing. I just absolutely had to. That's just my style of doing things, and that's what I had to do. All right, this thing definitely is no power monster by no means, but it can be driven a lot harder and get a little bit more output out of it. We're just going to use our bench radio right now. This is only doing about 16 watts PEP. $500-watt slug. Oh, yeah. So that's about 130. About 130. Oh, yeah. Now let me show you how close I was able to get the input of this bad boy tuned. Oh, yeah. You see it. Oh, yeah. Alright, this is on low, and on low engages this 27 with this 62 to ground. Oh yeah, so we're looking at the middle scale, so that's about 90 watts. Oh yeah, and the input tune doesn't change, it stays, oh yeah, just a little wiggle, not much whatsoever. And this bad boy is done. You know, it's got two 454s in it. I don't know how much life still left in there. You can drive this a little bit harder, of course, probably get, you know, 200, 250 watts out. But with this amp being as small as it is in this tiny setup, I'd just say run it about 100, 150 and just leave it be. So we got this thing refreshed for you, man, rebuilt. It took a lot more work than anticipated. If this amp didn't have some sort of sentimental value to you, man, I would have never done this amount of work, because the price on the amount of labor I had to put in this thing wouldn't have been worth it to a regular person, you know. They'd be like, oh, just take that amp, throw it away or whatever. But I know you wanted this thing refreshed. This is Mr. Lunchbox's 2-pill, y'all. All right. Let me get up and get on out of here. On to the next project. Got you some good long cable on here for you too, buddy. We'll get this thing shipped back to you and get the top put on there. Maybe I need to put a new sticker, but if I put my sticker on it, the list will be long with all the stuff I've done to it. All right, buddy, we're good and going. Old gatekeeper out here in Georgia. God bless y'all. Bye-bye.